So in this lecture, I've got several examples of triangles, and I want to either show that they're congruent or show that they aren't congruent without going through the trouble of showing all of those 6 pairs of correspondences that the definition required. In other words, I want to do this using some of those theorems that we looked at. So with these two, all I know are the side lengths. So immediately that's pointing me towards seeing if I can use the side theorem, because that's the only one of the theorems we talked about that doesn't have any angles in it. And I think I can do that because here's our pairings. The 12-inch sides match. The 15-inch sides are another corresponding pair. And finally, the 14-inch sides are also congruent. So this is what I need. Right now we've shown that there is a correspondence between the sides such that each corresponding pair is made up of 2 congruent sides. And that's the requirements for using the side congruence theorem. Okay, so how would I write this? Because remember, we're very particular. We have to be able to kind of pull the correspondences out of the congruent statement. So I'm gonna do the 12-inch sides first. If I start with side AC from the left triangle, then I have to start with side FD from the second triangle. Whoops, sorry, AC, that's not the 12-inch side. AC and DE. So from there, right, I kind of went here to here. Now I'm going to do the 15-inch side. So that's going to mean doing B next here and F here. And that's what I need. Now I have the congruence. So how about these two? Now we kind of have the reverse situation. Now we only have information about the angles. And while we do seem to have 3 congruent pairs, 75-degree angles match, the 50-degree angles match, and the 55-degree angles match, that's not good enough. 3 pairs of congruent angles are not good enough to show the 2 triangles are congruent. We're going to actually talk more about this in the next lecture when we talk about similarity. In this situation, it's possible that while the triangles do have the same shape, one could be a scaled up or scaled down version of the other. So in this case, there's no way to prove that the triangles are congruent. So this one is a little more interesting. We have these 2 smaller triangles that are put together to make the big one. We've got triangle ABD and triangle CBD. And those are the 2 I want to see if we can show are congruent. So we've got a bit of a head start. We're explicitly told that we have a pair of congruent sides. And we also have a pair of congruent angles. This angle here, the diagram says it's a right angle. And because this angle and the angle over here on the other side, together they make that straight line ABC. That means they must be supplementary. So this angle on the left is 180 minus 90, which is 90 degrees. So I actually have 2 pairs, one pair of 2 congruent angles here. All right, so this is starting to point me towards the theorem I'm going to use. I have a pair of sides, then I have an angle. If I can prove that the other side that makes up that angle, side DB, has a congruence there as well, then I'm home free. And we actually can do this. And there's a neat little trick to this. Think about splitting this triangle up into 2 parts. So we have A, B, D, and here we have B, D, C. So we were told that these 2 sides were congruent. We've shown that these 2 angles are congruent. And these 2 sides are also congruent because in the diagram, they're the same side. And a segment is always going to be congruent to itself because Of course, it's got the same length. So that's what we needed to show. Right? So now by the side angle side congruence theorem, these two triangles are congruent. And the way I would write this, I would say ABD, triangle ABD, is congruent to triangle CBD, right? And there's our congruence. Okay, so in the next lecture, we're going to talk about what it means for two triangles to be similar. And as you'll see, the definition of similarity is very similar to the definition of congruence. We're just going to kind of loosen up one of the two requirements.